This is take 2 for the question 13 on the mock test that I gave you. So the answer to this question is down here at 2.66 pH. If you need me to go through each step, just stay tuned. Okay, so for this question, we know that our volume of our base, our NaOH, is 0.01945 liters, and the molarity is 0.32. Our ethanoic acid, also known as acetic acid, and here's the formula for it. The volume is 0.0224. We don't know its molarity, and we need to figure that out in order to figure out the pH. And we also know the Ka is 1.8 to the power of -5. It's not in the question, but it is in the sheet that I gave you. And if you look here, ethanoic acid right here, also known as acetic acid, you go over and you see that it is 1.8 to the power of -5. So we need this number in order to figure out the pH, and you'll see that in a second. So this is given to us in the question, and it talks about the endpoint. So we know that at the endpoint, your moles of acid will equal to your moles of base. And if you remember, I gave you the formula, molarity times volume of acid. So the molarity of the acid times volume of acid, which when you times together will give you your moles of acid, will equal to your molarity of your base to your volume of base. Again, when you times this together, this will give you your moles of base. So I know our molarity of acid is the one thing we don't know. So I'm just going to leave that as molarity of acid times by the volume of the acid. So the volume of the acid is 0.0224. My molarity of my base over here is 0.320. And the volume of the base, 0.01945 liters. Okay. When I plug that into the calculator, I'm going to get my molarity of my acid as 0.277857. Okay, so this here is what this guy up here is. Okay, and so remember, with acetic acid, when it dissociates, it's a weak acid. So here I'm going to write out the dissociation of my weak acid, my acetic acid. Okay, so it's going to be equilibrium, H plus C2H3O2. Okay, so remember, this guy just kind of popped off, and that's why it's left here. So I'll put a little negative there. So we'll do an ice table for that. So initially we have this much, 0.2779. Okay, none of this. At the change, I'll have something's gonna come off. Add by x, 0.2779 minus x, and x. So we've all done the ice table before, so this should be a review. This will pass the 100 rule, so I could ignore that one. And if I were to write the Ka equation for acetic acid, I'm going to have, so remember, product over reactant, I'm going to have my H plus C2H3O2 over this guy, HC2H3O2. Okay, I know this value because we got that from the table. So that's going to be 1.8 to the power of -5. This guy is an x, this guy is an x, so it's going to be xx over this guy, which is this guy right there, 0.2779. Okay, so x and x will give me x squared, 0.2779, 1.8 to the power of -5. When I work that in the calculator, I figure out x squared and then square root it. I figure out that x is going to give me 2.2 times 10 to the -3. So this guy here is this guy here. Okay, that X, this guy right here. So I'm going to just draw a line here. Okay, knowing that this is my H concentration, I could figure out my pH by doing the negative log of H plus. So the negative log of the number I got, 2.2 times 10 to the negative 3, and that will work out as 2.66, and that is our answer.